So Thomas is talking about using HDF compression filters from Python.
Okay, so hi everyone. So I will present you HDF5 plugin. It's the name of a Python package, and the idea was to give access to a HDF5 compression plugin for people using HDF5 from H5Py, so from Python. So the idea was actually to make a packaging effort so people can easily use the HDF5 plugin filter, but underneath it's really the HDF5 plugin filter that gets used. So if I take, for example, a small file, so here I'm using a tool called H5glance to view the content, and I have 3 datasets. If I try to use with H5Py, this is all you write. You open the file, and then you access the data, and you can read it. So if I read this data, I play it, so I can read my data, and I don't know if anyone recognizes what this is. Okay, so this is where we are, but 60 years before, when they started to build the site. Okay. Okay, better this way? Yeah. So this is, so these data are not compressed, so I can read them, no problem. And now if I try to do the same with the compressed dataset, I get an error and can't open directory, but actually tries to find the compression filters and they are not available. So that's where the HDF5 plugin package come at hands to enable loading those filters from Python. And so what you have to do is, so if you can't read things with H5Py, it means it's not default in HDF5 and not H5Py. So you need to install HDF5, so it's available in pip and conda, and also recently as a Debian and Ubuntu package. And there are also a few compression filters that are available, not all of them, but some on Debian. And that will be installed on the system. And then you need to import HDF5 plugin. And when you import this package, it will register the compression filters that are included in it to the library of HDF5 that is used by the H5Py. And then you can display the compressed data. Okay, so if we want to write compressed data from Python, the same will apply. You can compress it with what's available by default, but if you need more, you will need to add the filters, and HDF5 plugin is a way to do it. So that's how you create, one way to create a dataset from H5Py with this function, create dataset, giving the path and the data. And if you want to add compression, this is what you could write. So here it's to use the Blosc compression filter. So you have to give the compression ID, and then you have to give compression options. And well, this is a series of integers that you have to pass. And what we propose in HDF5 plugin is to provide an API to define those parameters in a more readable way. And so we propose some classes for each of the supported filters, where here you can say, I want compression LZ4, I want the BitShuffle filter, and I want compression level 5. And that will make this for you. So it's more easier to read and also to find out, because there is some documentation. And this morning, Dana mentioned having some documentation on the register filtered, and I think that would be great, because for some filters, I had to look at the source code to find out what they were doing with the value you pass to know what was going on. So just a minimum text would be great on this. And so you can get some help on each of the filters. And so, yeah, we can look, it's the same data, obviously. And here, if I compare the file uncompressed and the compressed one, I have a small difference. So it's been compressed. It's not big because it's not the kind of data that will compress well with BitShuffle Z4. So I will make a tour of the filters that are available by default and inside HDF5 plugin. So first, libhdf5, it's been mentioned, provides some filters. Like as pre-filtering, you have shuffle, and as compression, you have gzip by default, and eventually sdip. And h5py also package one extra filter, LZF. So when you use HDF5 from Python, you will have this available by default. And this is one example on providing some parameter to enable shuffle and to say compression equal gzip here, and you will get the data shuffled and gzip compressed. Now, on top of that, HDF5 plugin provides as of today 10 out of the 29 registered filters. So I will go through them. And the idea is to do, you can do compression equal and the class in HDF5 plugin that correspond to the filter you want to use with some parameters. So in terms of general purpose compression filters, lossless, so you have BitShuffle, it's BitShuffle LZ4 that we've heard a lot this morning about. They recently added ZStd compression as well, so you can do BitShuffle plus ZStd with this filter. You have bzip2, LZ4, which is only LZ4 compression, and ZStd, which is only ZStd compression. Then you have a specific filter FciDecomp, which has some constraint on the data type you can pass. It's only integer of 8 or 16 bits and the number of dimensions that you can use. So it's limited to images, more or less. Then you have some lossy compression. So we recently added to HDF5 plugin the two A's of the SD family filters. So there are lossy compressions that you can control with specifying the absolute or relative error that you want. And you also have ZFP that Elena mentioned. It's the same. You can specify, you can control the lossiness by absolute or relative precision in a way, or the bit rate. And same, this one has limitation on the data type you can pass and the number of dimensions of the chunks. So it's up to 4D. And finally, you have the Blosc family. So initially you had the Blosc compression filter and now Blosc 2. They both provide a set of pre-compression filters, so shuffling, and you have a few more in Blosc 2, and then some compressions algorithms that you can use. So for now, we don't have full support, let's say, of Blosc 2. Like there is an extension to have ZFP inside Blosc 2. It's not yet available in the HDF5 plugin. There are a few things that are missing from the full Blosc 2 environment, and definitely extra filters as well, like like the high throughput JPEG 2K. That's things that will be added in the future into HDF5 plugin. And if you look at all those filters, there's quite a few equivalent filters. Like if Blosc and Blosc 2, they include things that are provided by other various filters, like LZ4, ZStd, and BitShuffle. So because it's a like meta compressor approach, it includes some of the filters, some of the compressions that are also available in other ones. So if we do a look on the performances, so I made a test on one of our cluster machine. I limited this test to a single core because yeah, we could do more with multiprocessing, but then you have to see which, like what Jerome explained this morning, the limitation you have depending on how you set your task on the hardware. So and keep simple. So that's a list of all the all the lossless compression filters. Here at the bottom, you have without data compression to have a reference in terms of speed. So blue is writing, orange is reading. And at the top, the most compression, it's using ZStd and BitShuffle with Blosc, which give the highest, in this case, compression rate. And what we typically are interested in is something that's compressed fairly well for those data. It's diffraction data, and with a good speed, write and read. And if you have good eyes, you can see it's Blosc LZ4 BitShuffle, Blosc 2, Blosc 1 LZ4 BitShuffle, and Blosc BitShuffle LZ4. So that's why, like for you heard a lot about BitShuffle LZ4, because this is a good trade-off between proper compression and good read and write speed. So some of the filters can support multi-threading. Like Blosc and Blosc 2, you can configure the number of threads. The decompression and compression can run on with Blosc and thread environment variable. And for BitShuffle, FciDecomp, the SZ and ZFP, they are implemented with OpenMP. And so OpenMP, you can enable it at compilation time. And for the binary package that we provide for pip and conda, it's disabled by default to optimize the compatibility with the platform. But if you build it from source, you can build it with OpenMP. And once enabled, you have to set this OpenMP OMP num threads environment variable that Jerome mentioned this morning to configure the number of threads. But if you have other processing using OpenMP, then this will configure the threads for the whole application. And yeah, performance do not increase linearly when you add more CPU cores in this case, because if you are on if you're dual socket and you have some of the cores on one socket, some on the others, with the slow interconnect, you can get problems and so on and so forth. And the chunk size of the data also, the HDF5 chunk size might make things vary, because if the chunk is quite small, it will span some threads to do the processing for a little amount of data and things like that. So in summary, the idea is to have different pre-compression and compression algorithms, so you can have different trade-offs. If you want high compression, fast read and write, or different error rates for lossy compression. But also, and I think you should keep in mind what's available. I mean, the simplest, if you want to compress your data, is to use gzip, because anyone using HDF5 will have it. But then you have something that's quite slow to do the compression. Finally, also as an extra, you can use HDF5 plugin in other non-Python application, at least for reading, because it embeds some HDF5 compression plugins. And then you can get the path where those plugins are. It's the dynamic libraries, and you can set the HDF5 plugin path environment variable to this value, and you could use those filters like in MATLAB for reading your files. It won't work for writing, because it needs some filters needs to call the HDF5 library, and then in this case it will not work. So it's open source, and like the code of HDF5 plugin itself is MIT, but it embeds mostly a lot of code from third parties, all the filters, all the compression libraries that are available in a variety of different open source licenses. So I wanted to have a few words on the limitations that I see of the overall plugin mechanism. But I mean, if we reach limitation, it's because we heavily use HDF5. So yeah, only gzip is available by default, and I think we because we all use BitShuffle HDF4, it's because we need some different trade-offs. And that would be great if those different trade-offs will be attended by default. But I think it's not the way you want to go, as you mentioned this morning. And if I had to choose one, I would choose Blosc because it provides different alternatives in one API. Also, when we were looking to add filters to HDF5 plugin, I was always wondering which version is the ground truth, which is upstream. And so, as you mentioned, having some central place, central repository, or whatever the form it is, will be great to know, because as it is now, there are different copies of the plugins, and HDF5 plugin is one more. So that would be great to be clear where to find the source. And why we had to do HDF5 plugin to enable writing, we had to do a hack because the filters, they need to be linked with HDF5, because some filters, they need like the data type to do the shuffling, or they need the shape of the chunk, so they can, like ZFP, they use the shape of the data to run the compression. And having this link might be fine when you install system-wise, because you know the library, might be fine when you do a standalone application. But when you run in Python and you install H5Py, you have no clue which is the libhdf5 that is used. So in HDF5 plugin, what we do is like we provide some stuff of HDF5 for the plugin, and we load the HDF5 library symbols at runtime, and then we replace the stub with those. And finally, in terms of performances, so it will be great to have multi-threaded access. Like when you have chunks in HDF5, some of the library, like Blosc, can access smaller bits. And if you don't need to read the whole chunk, but for instance, one line of the image or something like that, it would be great to have access to the lower part, so you can only decompress the small bits that you want to read. And finally, and I will give an example, but there are some memory copies due to the way filters are currently implemented and H5Py on top that could be spared and that could improve performances. And all this can now be mitigated with a direct chunk access, because you can handle it by yourself, but then you have to do it. And so just to give an example on memory copies, so if I have a dataset compressed with Blosc2, BitShuffle NZ4, and I access this, I want to read it with H5Py the standard way. So just return me an array of my data. It takes about 9 milliseconds. If I use the function readDirect, which will fill an array with the data using libhdf5 to do the decompression, it's 5 milliseconds. And if I read the compressed chunks from the file directly, and then I do the decompression from Python, I can go faster. And it's all doing the same. And there are a few memory copies here and there that I think could be spared, and would be great if you guys at some point reconsider how filters are defined. So I want to thank people who contributed to the HDF5 plugin so far, and also to the contributors of all the embedded libraries, because there is a lot of work from source code that we copied into this to make it available for users, and also to the HDF group for the HDF5 library. And finally to David, who's been organizing this event here for hosting it at DAISY. So to conclude, it's HDF5 plugin. It can be installed from pip or conda, and you have the repository here where you can find also the documentation. So thanks for your attention, and I'm happy to answer your questions.
So questions from people? Sorry, I didn't see the hand there.
Thomas, thanks for the presentation and all these nice features. I was curious about, I like the slide with the comparison of different methods. is it in, do you have any tool that can, for example, generate this such a table, yeah, for a data set that I would have?
Yes, I made a script to run this and a notebook to do the plotting. It's available on it will be available on the repository. It's in a pull request now, but I will add it to, I usually add the presentation to the documentation, so it will be available. I can send you the link if you want.
Okay, thank you.
Yeah. But yeah, I didn't mention, but basically I take HDF5 data from diffraction tomography, and it's reading like 100 frames out of it to have the timings, reading and writing. Well, writing and reading then.
Thanks for your presentation and for your work. Do you happen to know if LZO is also part via your plugin, or PyTables does it separately?
We definitely don't have LZO in this.
Because I almost thought I saw some similar effect that if I import something else, then it works also on H5Py, but maybe it was via PyTables then.
Yeah, sorry, I am Francesc Altet from the PyTables project as well. So yeah, we have been supporting LZO since many years ago, probably more than 10 years. And if you are using it from H5Py, it's because probably there is some kind of method or hidden method that after installing PyTables or importing tables, the tables package, you can use LZO from H5Py. I think, but I never tried it myself.
Thanks for that comment.
Also, I have a question for Thomas. So thanks very much for the presentation, very nice. Yeah, it's interesting that you are trying to do the API more flexible, especially for codecs like Blosc that accept a lot of different properties and parameters. I think we should be in touch because as we are supporting dynamic filters, there will be a need to pass a different, well, quite generic set of parameters to different plugins that can be used by Blosc too. So yeah, it is nice that you are already doing this, following this path by making the API more flexible. Just we should talk on doing even more flexible for Blosc too. Thanks.
Yeah, as it stands now, it's like the HDF5 plugin.blosc class that you have here. It's just a way to define the parameters to HDF5. So basically, it's just set the compression and compression options in H5Py, create dataset. So it's it was to make it easier for people to use, but it goes through the same libHDF5 filter CD values that you have to define.
Yeah,
but yeah,
and
we definitely need to discuss this. I agree.
Yeah, because there's going to be a lot of different parameters. For example, for our recent work for JPEG 2000 is going to be a lot of parameters. But yeah, let's talk offline. Thank you.
Yeah, and also as it stands, it's providing pre-compiled compression filters. So for Blosc 2. So I don't think it will leverage like installing extension via pip.
That's another thing. Yes.
Yeah.
Yeah. Anyway, let's keep in touch.
Yes.
Yeah, thanks, Thomas. I think it's a great work. It's used by a lot of people. But I was wondering, just on a more philosophical level, does this work? Is this its natural home, or should it more be part of H5Py or part of libHDF5? I mean, is this a workaround about something which could be integrated? Maybe for the discussion tomorrow, we could see if there's something, an even better way of doing it.
Yeah, I think this is something we should discuss. But I mean, we already started at lunchtime. I also completely understand that HDF5, HDF group or H5 doesn't want to get into all third-party compression filters and that get the burden of maintenance of them by themselves. So I think we have to find a middle ground where everyone is happy with the situation. So it's not a burden on the HDF group. It's not like the Wild West of compression filters everywhere. So yeah.
So any other questions?
And yeah, finally,
comments,
I think we should focus on a few filters because the more filters there is, the more we have overall people have to maintain, or the more there is chance that things will be dropped and no one will maintain them. So yeah.
Mostly comment for the HDF group. We had RFC with the configurable options to which we pass as strings, and it was for any plugins, like it was developed for all John Mainer's proposal that was still under discussion. So I guess this will be needed. So there is some ideas already in works to have passing parameters for different plugins, and also remembering that plugins may be stackable. I can find that RFC, I don't remember, but we were going to look into it because we will need it. Yeah, but the point is that it, first of all, it's needed. This is another use case, right? And we probably need to move on it.
So there's another question or comment up the back here.
So I'm just thinking about these sort of equivalent filters that you were describing. So there's obviously a lot of these things. There's kind of the same thing inside Blosc and outside Blosc. And I think the way it works at the moment is that like Blosc has its own filter ID in HDF5, which is then like kind of meaningless because Blosc compression can be like just about anything. Like, should we instead be thinking about like, you know, Blosc LZ4 being identified as LZ4 compression, and then like there are different implementations of that? This is kind of a meta question, sorry.
Yeah, but I mean, you need the filter. They all store the data differently. Like LZ4, I think it's just passing the data to LZ4 and putting it in the chunk. As the standard expect the same. BitShuffle LZ4, they do the bit shuffling on top, but they also add a small header. Blosc 1 has its own frame of data, Blosc 2 has another one, and so on and so forth. So the algorithm underneath it's the same, but the way the data is stored is different.
Okay. So any other questions or comments? Okay.
Sorry, I have a comment, and I still don't understand why plugins should be linked with HDF5 library. So if someone can explain outside this, because sometimes you can build the library, but dynamic library, and not resolve all symbols. So something is going wrong here. And I was fighting developers for quite a long time now. No one can explain to me.
Okay, when you are in
so when you
are in Python, all modules are not loaded, all symbols are not loaded, but on Windows. So when you load H5, the symbols of HDF5 are not available for everything else. It only exports the initialization function of the Python.
but without Python, for example. You should be able to build shared library without linking with another library.
Yeah.
So I do
That would
see
be
a
great,
comment
yes.
up the back. Well,
I could spare this, but
At Daisy, we are using also H5PY, and we are installing all the filters from Debian packages, and we don't need this H5PY plugins because they are already installed with the system. So that's, I think it's only when someone is using pip or conda or Windows, and if someone install H5PY not from the Debian packages, but for example from conda, from Wheels, they do not have access to the installed filters on the system, and that's the problem.
yes, exactly. Yeah, if you install everything on the system, then
So I think we maybe move on. In fact, no, we have one more comment.
Yeah, yes, I have a comment on your approach, because at Daisy, apparently you're taking a clever way of using an operating system which includes properly packaged stuff, but the general tendency is to go towards containerized stuff, where everybody does quick and dirty stuff inside the container, hiding stuff in it. And as a consequence, that's the kind of issue we will have to deal with. So as soon as you start playing with some kind of Docker or stuff like that, you end up by needing to install the plugins inside the container. And yeah, that's it's one way to address the problem. But I totally agree with the fact that the way you are taking is more clever and more sustainable on the long run, but it's not the path that most facilities took.
Okay, so I guess we'll say thanks again and move on to the next speaker.